So the homework was from last day, vector operations, A plus B. Now, believe it or not, I was given this way back in 1988 from my first year physics university prof, this same handout. And I've always, I haven't been able to edit it, but it gets its point across. The only thing is really it should go number 1, number 2 should be right here because A plus B should be followed by B plus A. So I'm going to work across. Anyways, A plus B looks like this. Vector A, vector B. There's the resultant. B plus A looks like this. Vector B, vector A. There's the resultant. And Rachel, if you're particularly observant, you may notice that A plus B and B plus A give you the same resultant. And what I want you to realize is, much like with arithmetic, when you're adding vectors, the order doesn't matter. What's 5 plus 3 in your head? What's 3 plus 5? 8. Now, if you're subtracting vectors, how do we subtract vectors? I don't, I add the opposite. But if you're subtracting vectors, order does matter because 5 take away 3, 2, is not the same as 3 take away 5, negative 2. You'll get the right length, but the wrong direction because of the negatives. Anyways, for what it's worth. C plus B would look like this then. C, yoink, plus B, and the resultant would be something like that. Oh, I did B, C plus A. Whoops. Thank you. It was looking weird to me. Thank you. C plus B, and the resultant is something like that. And you also get the same thing if you go B plus C. You still get a resultant down and slanty. A plus C would look like this. And if they gave me numbers, that would be a cosine law, sine law question. A plus B plus C. A plus B, which is kind of that, plus C. You know, I kind of think you almost get 2 C's. I don't know. I'd need some actual numbers to be confident of that. But A plus B sort of looks like vector C. So I think A plus B plus C is sort of the same as 2 vector C's in a row. A minus B. How do I do A minus B? I don't. I add the opposite. So it's going to be A plus negative B. A, B would be down, negative B would be up. There's A take away B. 2A. And there's how you multiply a scalar times a vector, which most kids find pretty obvious. Oh yeah, twice as long. B minus A, I don't do that. I do B plus negative A. So I have B plus A would be to the right, plus negative A will be to the left. And going back to Rachel, you can see, oh yeah, just like 5 take away 3 and 3 take away 5 give you the same magnitude but opposite numbers, negative 2 and 2, you get the same magnitude but opposite direction. So definitely subtraction, order matters. And then in number 10, I think you're going to get A plus B. And then I think when you, minus C, which is plus negative C, I think you actually kind of end up, in fact, I might even say if I had numbers, it might be 0. You might end up back where you started from, but Shaq, I can't quite make that until I know what the values actually are. But your picture should be something like that. Is that all right? Thumbs up. I'm not going to collect that one. I also assigned some homework from the Great Big Review. Again, the rule in my class is if you have questions from the Great Big Review, go to the website, look at the online solution key first, then ask me. The online solution key is there showing all my steps. So I'm not going to take questions from any of the review there. Instead, we're going to slow down a little bit and we're going to do a review of projectiles, but I'm going to be teaching it from scratch because I'm not sure we got through all of projectiles. And this is also going to review some of the D equals VIT plus a half AT, VF equals VI plus a VF squared equals. So you're going to probably, unless you still have those memorized, you're going to probably want your handy dandy formula sheet in front of you. So, projectile motion, part 1. Tomorrow, projectile motion part 2, And then we're sort of done Unit 1. We'll be doing some reviews and some quizzes. Right now, I'm kinda hoping to throw your first test at you maybe at the end of next week or the beginning of the week after. I'm gonna be kind of flexible because I've really hit the ground running more than I normally do with the late start. I haven't done anywhere near as much review as I normally do. Having said that, in theory, this is all review, but I'm going to pretend you forgot it all. A projectile is an object in free fall. We're going to always be ignoring air resistance. We're going to be in our magic physics world where everything works out nice. You already did free fall one-dimensional projectiles last year in Physics 11. So we're going to look at two-dimensional projectiles. And the key idea is that when we're looking at a projectile, we can really treat it as doing two things. Zach, we can treat it as being in vertical free fall, and we can treat it as moving horizontally. And we can treat them completely separately as long as we understand what's going on each of those situations. Example 1. Suppose a mass is held at shoulder level and it's fired horizontally. Which curve best shows the path that it follows to the ground? Path A, path B, path C, or path D? Which curve best shows the path it follows to the ground? What you're going to do is you're going to vote by holding up your hand. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Dueck is going to keep track, and if I don't vote at all, he'll make fun of me. Okay? Positive. Pretty sure. Voting because Mr. Dueck wants me to have an opinion. So, looking at that picture, who thinks that if you launch a projectile from your shoulder horizontally, it'll follow path A straight down? Who says path B? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who says path C? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Who says path D? Oh, there's hope. So now that we've voted, each of you has a choice. You can either defend your own answer as being right or attack someone else's answer as being wrong. You can attack or defend. Convince me. Seems to be between B or C. Convince me.
Wait a second. Is it like being thrown or just kind of like,
Let's have it being fired from an air cannon level on my shoulder like a bazooka. Zach.
It's not gonna go straight. Like gravity's gonna be pushing it down no matter what. It's not gonna go straight.
So the split second that leaves your shoulder, it's going to be in a word that begins with the letter F. 2 words that begin with the letter F. It's going to be in free fall. The split second it leaves your shoulder, it's going to start to fall. So which of these is wrong of the two main selections? Okay, you know what? No, no, and no. Now, those of you that picked C, hopefully you misunderstood the question, but there is a problem. You have been taught cartoon physics and you have been taught movie physics. For example, in movie physics, bullets travel in a straight line. They do not. They do not. If you watch a movie and there is a sniper and they show the sniper aiming through the scope and he lines the crosshairs on the target, but then when he pulls the trigger, it takes a second before the bullet hits the target, that's garbage. The bullet is falling just as fast as this. How far will this fall in 1 second? 1,001, well, probably from ceiling to floor. That sniper should be aiming 3 meters up, the crosshairs should be 3 meters above the target, and then maybe the physics would be accurate, which, by the way, is why it's so tough to be a sniper. Otherwise, all you'd have to be able to do is line up a little X on a target. They would all take, no, it's not how it works. It's not how it works. Bullets start dropping as soon as you fire them. They don't travel in a straight line. Cartoon physics, you grew up watching, for example, the Roadrunner run straight or the Coyote run straight into midair, and he only started falling once he realized that there was no ground beneath him, but he continued going straight. No. objects start falling as soon as they're in free fall. So where it says defend your answer, I just did. This brings us to our next thought experiment. Suppose you have two identical objects and they're held at the same height above the ground. And just to make Mickey happy, let's make these bullets from a high-powered rifle. Okay? Both of these are bullets. We're going to pull the trigger, and bullet number 2 is going to be launched horizontally, and at exactly the same time, we're going to drop bullet number 1 in free fall. Which one hits the ground first? Once again, we're going to vote. So we have A, object 1, since it has a more direct path, B, object 2, since it's moving faster than object 1, or C, they both hit at the same time. Who says A, object 1 is going to hit the ground first? Rob twitched. He went with it. Was that a vote, Rob, or was that?
No, just scratching my...
You sure? That? Because here's what I saw. I saw the hand go up. When it got to here, he looked around. His eyes got really big, seeing no other hands are up, and then he morphed it into a, I want to feel the stubble. That's what I saw.
I didn't even go to my cheek.
I saw a stubble. Okay. Okay.
Put me down.
I don't know. Only you know your heart of hearts. We know better. Whoop, pen just about got hooked on the string. That would have been silly. Object 2, who says B? You got that twitch.
I just did that one.
Who says C? Convince me. Convince me. Oh, by the way, I think in the last one, I forgot to actually circle the correct answer. So B, yeah, right? I tend to do that. I get so caught up in the argument, I forget to circle the correct answer. This is one, again, that bugs people. People that don't have a physics background will tell you that bullets travel in a straight line. They don't. And again, going back to the sniping example, not only do the snipers have to take into account how far it's going to drop, if they're doing a really long-range shot, they have to take into account the curvature of the Earth. Go figure. There's a reason why. You know, not anybody who can line up an X through a sight and pull a trigger can be a sniper. It's much more complicated than that. Okay? They both hit the ground at the same time because they're both in free fall. Now, we are ignoring air resistance, but Mythbusters a few years ago decided to test this, and even with air resistance, they were able to get 2 bullets to drop, and they both, the one bullet that was fired straight hit at exactly the same time within about 0.03 milliseconds or something like that of the bullet that was dropped to the ground, and they managed to get them both into the same frame. They figured out where the bullet fired horizontally would land, and they dropped the other bullet right there, and you saw them both hit the cement at the same time. It was beautiful. It's beautiful. By the way, those of you that watch Mythbusters, big changes next year, right? Cary, Grant, and Tori are done. They're moving on. So I'm a Mythbusters fan. It says explain your answer using relevant physics concepts. Both objects are in free fall. Which means what? Which means vertically, what are they accelerating at? Negative 9.8. And both of them have an initial vertical velocity of what? 0. Because one's being dropped, and dropped means Vy is 0. But if you're being fired horizontally, you may have a horizontal velocity, but your initial vertical velocity is 0. And this is where we're going to start to talk about the fact that you can break any projectile up into its components. What this important demonstration shows us is that the vertical and the horizontal motions of a projectile are really independent. This means that what happens horizontally does not affect what happens vertically. Basically, what this means is if you're sitting in the back of a pickup truck, and if we ignore air resistance, so we do have to, Brendan, go into our magic physics world, no air. If you were sitting in the back of a pickup truck on the moon, and you fired a bullet straight up while the pickup truck was moving at a constant speed, that bullet's going to come back down and hit you in the head. It's going to follow right along the pickup truck the entire time because it's got a horizontal component from the pickup truck and a vertical component. Well, you know what? I got a video that can show you. So let's break it down even further. Next page. if you look at a stop action, if you look at a strobe photo of a projectile that's been launched horizontally off of a cliff, what you'll notice is that horizontally it's moving at a constant speed, but vertically it's speeding up. I found this one color diagram, and then I also did a black and white one for you, but Vx is constant and Vy changes. How come? Well, the key idea here is the horizontal acceleration. Can I abbreviate that as AX? And the vertical acceleration, can I abbreviate that as AY? What is the vertical acceleration for any projectile? You should remember this from last year. Negative 9.8. And what that means, Jordan, because meters per second squared, because there is an acceleration, you must have a changing speed, because the definition of acceleration was a change in speed over a given time. What's the horizontal acceleration? Nothing. And if you have no horizontal acceleration, what that means is your horizontal speed has to be constant, because that was the definition of constant speed. What we're going to do to solve projectiles is we're going to break them down, Grayson, into the horizontal and into the vertical components of the situations. You are going to have to memorize or understand that vertically the acceleration is negative 9.8, horizontally the acceleration is 0, and Grayson, that bugs kids. The horizontal one. They so want to put an acceleration in that they want to put the 9.8 into the horizontal. No, horizontally, no acceleration as a number 0, which actually makes the horizontal math much nicer, because you've noticed anytime things are zeros, stuff cancels and we were happy. Example 4. So consider the stop action picture. Here is a projectile launched from the ground at an angle. At each point along the path, indicate the velocity components. You know what? Let's do the horizontal components first. So I drew in the first one. What would the horizontal component be at that first section right there? Exactly the same as the first one. There's Vx. What about at the top? Exactly the same as the first one. What about on the way down? Exactly the same as the first one. I'm trying to draw it the same length each time. What about right before, a split second before impact? Exactly the same as the first one. What about the vertical component? Well, the initial vertical component is that big. How does that compare to the vertical component at the next location? Bigger, smaller, or the same? I heard someone say bigger. I heard someone say smaller. Which one? Okay. Vertically, it would have slowed down. What would the vertical component be at the very, very top for a split second? Nothing. It doesn't mean it stopped. It's traveling horizontally. All it means is for a split second vertically it's come to a stop. And then on the way down and right at impact, it would be the same as what goes up must come down. So part A says, at each point along the path, indicate the velocity components. Check. What happens at the top? Vy is 0, but Vx is still constant. And what can be said about the projectile when it is just about to hit the ground? The final vertical velocity is negative the initial vertical velocity. If the initial vertical component was 5 meters per second, the final vertical component will be negative 5. Now, Rafi, that only works if you're starting and ending on the same height. This doesn't work from a cliff. But from the ground, it's really what goes up must come down. So I have here indicate the following key facts about projectile motion and indicate the velocity components. So the velocity components we would have Vx and Vy. At the top, what can you tell me about Vy? What about when we're even with our launch height? What can you tell me about Vy? What about just before impact? That's a problem. Well, to be honest, what we would use is we would use Vy final squared equals Vy initial squared plus 2ay dy. And Grayson, I'm just emphasizing, make sure you use vertical, 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 vertical. And you can find the vertical velocity when it hits the ground. Then what you could do is you could draw Vx tip to tail to Vy final, and you could even find the slanty velocity that it hits the ground at, whatever it is. We're going to do that later on, either in this lesson or the next one. So horizontal speed is constant because ax equals 0. Vertical speed is changing because ay equals, coming back to you a little bit, I hope, right? Negative 9.8 meters per second squared. And then here's the nice thing. Horizontal and vertical velocities are independent of each other, which means you look at one, you look at the other, and you can treat them as separate components. The only thing that will be the same for both of them will be time of flight, because you're traveling sideways for the same amount of time as you're falling, which you may recall from projectiles last year meant that most of the time you were spending most of your time finding time. And that's not meant to be a joke. Just you spent most of your time finding time. Example 7. Let's launch from a cliff horizontally. It says find the flight time and the range of this projectile. And what I tend to do anytime I'm dealing with a projectile is I use a big T-table and I break it up into horizontal and vertical. I type that for you. If they hadn't put that for me in the notes, then the first thing I would have done is I would have gone horizontal and vertical, but I did that already. And as soon as I do horizontal and vertical, the next thing that I write, Jordan, I can't call this a no-brainer because you need to know physics to make it a no-brainer, but once you know physics, hopefully it's a no-brainer. The next thing I always write is ax is 0 and ay is negative, ay is negative 9.8. I do those without thinking. Oh, sorry. As long as I'm on the Earth. If I'm on a different planet, the 9.8 will be a different value. Will we ever be on a different planet? Hopefully in your lifetimes. Then I start filling stuff based on what the question has given me. So what else do I know from the question? I see that 20. What's that? Okay. You know what? I'm actually going to call it Vx is 20. I scribbled out V initial. Why did I scribble out V initial? Because I want to emphasize that horizontally, what can you tell me about the initial and the final and the middle velocities? They are all the same. And so I tend on the left hand, on the horizontal section, just to really drum it home, Brent. I don't like writing initial because that might make me think it's changing. Vertically it is. And in fact, I would call this VI, I would add a little y there for vertical. And I would say to myself, what is the initial vertical velocity if we launch horizontally from a cliff? 0, which bugs kids. A lot of time, kids want to put a 20 there. No, that's horizontal. We're in vector land now, Mark. We're in 2 dimensions. We will be for most of this year, so you have to be very careful. 0. How many pieces of information do I have in the left column? 2. How many pieces of information do I have so far in the right column? 2. This is not enough. You're always trying to find that third piece of information, because once you find that third piece of information, you can use 3 to find 4 of anything else. You have to find the fourth. So what else do I know? I go looking at the picture. Oh, there's a 50. What's that? It's a trick question. Technically, 50 is nothing. I'm being very fussy here. Negative 50. Why negative 50? Because we're in vector land. First of all, it's vertical, so it's going to go in the vertical column. But Zach, are we ending up above or below from where we started? We have to tell the universe that we noticed that. Otherwise, we'll get wonky errors on our calculator. So I'm going to call this dy, and I'm going to say negative 50. And now that I have that, my path is set. Mark, do you notice in one of these columns I know 2 things? Then I can find a fourth thing. T equals. I'm looking for an equation that has VI, A, D, and T in it. Hopefully there is one. Which one? Good old, the quadratic, what D equals VIT plus a half AT squared. Now, in your prime last year, and maybe as you get good this year, you may, in the homework, in your head, already rearrange that equation to get the T by itself. But in our notes, let's show all our steps because we're brushing off the cobwebs. So Rachel, I'm actually going to write dy equals Vy initial T plus a half AY T squared. And you can see, Naomi, I'm emphasizing vertical, 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 vertical. Oh, but since T is a scalar, I don't put Y's on the time. It's a scalar. Are any of these 0? Oh, I can do this. It's convenient. Okay, so let's see if I can get the T by itself. Now, really what we have then is this. dy equals AYT squared over 2, a half AT squared. You did this one a bunch last year. It was times by 2, divide by A, and that got you the T squared. Shaq, how to get rid of a squared? Square root, we're back, right? So, Shaq, if I hear you correctly, you're saying now, the nice thing about this, do you remember how I had to kind of drag that negative 50 out of you? What if you forgot that it was a negative 50? What if you just put a 50 in there? Brendan, there is a built-in error check because you would go 2 times 50 divided by negative 9.8, and when you tried to take a square root, you get an error, and that's the universe saying, I'm sorry, what you're asking me to do is impossible under the laws of physics. Go check your data. So it's going to be 2 times negative 50 divided by negative 9.8, square root of that, 3 point something. And I get, is this my final answer? What's this question asking me to find? What was this question asking me to find? Okay, I'll call that part A, and then part B. So this is part of my final answer. I'm going to write T equals, I'll carry a few extra sig figs. I'll go 3.1944. But my answer to A itself, which wants time of flight, final answers always to 2 or 3 sig figs. So I'll say T equals 3.19 seconds. There's the answer to the first part. Coming back to you, I hope. Oh, and the next thing I would do, Mac, is I would go trundling off over to the horizontal column, and I would say, ha-ha, I now know time. Which means, Brendan, I now know 1, 2, 3 things in this column. Which means I can probably find the horizontal distance, the fancy word for which is the range.
Is that why they call it a firing range?
Yeah, that's why they call it a firing range. Okay. So I'm looking for an equation that has V, A, T, and D in it. Holy smokes, for part B, I can use dx equals vxt plus a half ax t squared. Same equation as before. Are any of these 0? Cool. That whole term cancels. Which means, I guess, the range is just going to be 20 times 3.19, which is going to be, can I do this in my head? 20 times 3 is 60. 20 times 0.2 would be 64? 63.9 something, yeah? 63.8, I'm off, times 20. 63.9, it's 8, yeah, 63.9. Units, meters. I've been off for the summer. I got to get my mental math back into the game here. That's cliff horizontally. Where does it get tougher? When you're no longer launching horizontally. Well, it gets a bit tougher. If you launch at an angle, we will not deal with this. I mean, we will for a bit in that I'll expect you to handle it, but what I'm going to do is I'm going to convert this into something I can already handle. I'm not going to deal with 100 meters per second at a 35-degree angle. I'm going to break it up into what? I'm going to break it up into its components. I'm going to break it up into Vx and Vy initial. How come I put an initial on the Vi, on the Vy, but I didn't put an initial on the Vx? Yeah, and any chance I can drum that into my brain subconsciously, I'll take that. Oh, and conveniently, it's less writing, so it's like win-win. Let's see. Opposite, adjacent, hypotenuse. What do you want to find first, Vx or Vy? I don't care. Pick, Zach. Okay, find Vx. Which trig function can I use to find Vx? Cosine. Yes. See it? Ah. Right? Okay. So I'm going to say this. Cosine of 35 equals Vx over 100. So Vx is going to be 100 times the cos of 35. And I get, I'll carry extra sig figs here because I'm going to be using this to find my, they didn't ask me to find Vx, this is not a final answer. So instead of going to 2 or 3 sig figs, I'll go 81.915. And I'll put that right here. And I'm going to be fussy, and I'll make the I into an X just to really reinforce with myself, no need for an initial. All right, let's find Vy. Which trig function? Sine. Vy initial over 100. Knock, knock, who's there? 1 fraction equals 1 fraction. Stuff moves diagonally. The 100 moves to the top again, right? We're dividing by 100 times the 100 over, and we get Vy initial equals 100 sine 35. And I get 57.358. 57.358. 57.358. And I'll drop that right here. 57.358. By the way, what if instead of pointing upwards, what if we were on the edge of a cliff pointing downwards at an angle? How could I show that I was shooting this downwards? The Vx would still be positive, but the Vy would just have a negative in front of it. Okay, I can deal with that. I don't know if I'm going to give you one like that in the homework or on a test or on a quiz, but as far as I'm concerned, if that curveball came along, I could handle it. Oh, we got our t-table. I said there's always two other things I do right away. I say ax equals 0 and ay equals negative 9.8. Those are my, I can't call it a no-brainer because you need to know physics, but hopefully they're physics no-brainers by now. How many things do I have on the left-hand column? 2. How many things do I know on the right-hand column? 2. It's not enough. There must be something else. And there is. Don't write this down, just watch. I do know, don't write that down. At impact, because we're starting on the ground and ending on the ground, what's Vy final? Negative 57.3. Now, the reason I said don't write that down is because actually part A isn't talking about the ground again. What does part A want me to find? Time to top. Okay, what do we know at the top? Zero. Sorry? Someone said it. I think it was Mark. Okay. What'd you say? At the top. Okay, I got to be careful of making sure we understand at the top. Vy final is not 0, Brendan, at the bottom at impact. At impact, it's still moving. Yes, it's 0 after impact because it comes to a stop, but that's boring. We don't answer that. So now I have ay is negative 9.8. I have Vy initial equals 57.358. What do they want me to find in part A? What are they asking me to find in part? Oh, I'm looking for an equation that has V final, V initial, A and T in it. Having a little deja vu here. What is the equation that has V final, V initial, A and T in it? Can you get the T by itself in your head, please? See if you can. Yep. VF minus VI over A. And the only thing I would do this year, Eric, is to say add vertical, just to make sure I don't accidentally put the wrong value in, which is by far the most common mistake with projectiles. Kids put a vertical into a horizontal or a horizontal into a vertical, and then I freak. This is going to be 0 minus 57.358 all over negative 9.8. Time of flight is going to be, oh, I still have this stored on my calculator. So, Brendan, how many numbers are on top of that fraction? No, how many grand total? How many terms are there? 2, did you say? You're right, say it again. So will I need to put the top in brackets or not? Say yes. I think yesterday that was one of your issues, right? Any chance to reinforce? I'm going to use my answer button instead of typing 57.358. I'll use the 57.35764, blah, 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 divided by negative 9.8. Time, positive or negative? So hopefully I get a positive. Woohoo! Apparently gets to the top 5.852. Oh, final answer, 2 or 3 sig figs, 5.85 seconds. Cool. What does part B want me to find? Oh, I guess I better scroll back since no one's answering. Total flight time. There's a quick, short way, and there's a longer way. Can anybody see the quick, short way? Mickey, my angel. Pause. We're back. What does part B want? Total flight time. What's the quick, easy way to find total flight time? I'll call that T total. Because we're starting on the ground and ending on the ground, there is a shortcut that I can do with my answer from A. Somebody see it? I just times by 2. Okay? So I'm going to do that. I'm going to say it's time from A times 2, or however you want to write that. And I still have this stored on my calculator. So 11.7 seconds. The only problem is I'm using an answer from A to get an answer for B, which means if A is wrong, what have I just guaranteed? Okay, B is wrong. You know what? I'm pretty confident, but if this was a test and I finished early, I can solve this another way. The second way, I can still use Vy initial equals 57.358. I can still use AY is negative 9.8. But because now I'm talking about hitting the ground, I can use Vy final equals negative 57.358. Grayson, I can use basically what goes up must come down. Really what that is mathematically is what I'm saying there. And I could go T equals VF minus VI over A, and I'll get the same answer. Hey, let's convince myself. Bracket negative 57.358 minus 57.358 divided by negative 9.8. There you go. We're accurate to the first 1, 2, 3, 4. We're accurate to 5 sig figs. On the 6th sig fig, we got a bit of an error. I'm trusting you with that a little more than I should, it seems. Be careful. Thank you. Yes, because Nerf is so dangerous. I would argue if you get removed or injured by Nerf, we don't want your genes in the gene pool. We'd kind of prefer Darwin didn't. You know, I'm just saying. Rob, what does part C want me to find? The range? Range, is that horizontal or vertical? So I call that dx. What's ax, Rob? Is that correct? I don't think so. A is acceleration. So what's ax from my t table? I think I wrote it there, did I not?
Yeah, 0.
Oh, 0 you say? Okay. What else do I know? Horizontally, what do I know? Oh, what's Vx? What's T? You know what? I can go dx equals vxt plus a half ax t squared. Hey, that's going to cancel again. I'm going to get 81.9 times 11.7, and I can find the range. Range looks like it's 958 meters. So we've looked at, not too bad. We've looked at ground angle, little more work. The toughest is cliff angle. There are several strategies that you can do. The first strategy that you can do is you can find how long it takes to get to the top, then start over, find how long it takes to get all the way down to the bottom, add those two times together. Remember I said you're going to spend most of your time finding time. Strategy number 2, you can find time all at once. Strategy number 3, you could find the time to the top, double it, because that would get you the time back down to cliff height, and then figure out how much longer it falls. I really don't recommend strategy number 3. I'm not much of a fan of strategy number 1. I really prefer let's do it all at once. I like example 10, I like example 10, I like example 10. Example 10 is a nice question. Why would I say that? Did you hear me say it was going to be on the test, or you're just kind of the student that tends to notice those things? Okay. This, as far as I'm concerned, is Physics 12. In Physics 11, last year, in the projectile unit, you did do cliff horizontally, you did do ground angle, but we couldn't really do cliff angle because you need to use the quadratic formula, and we can't assume you had it yet. Did I say the word angle? You know what that means? This is a job for what? I heard someone say it begins with the letter C. Components. We're not going to deal with stuff at angles. I'm going to break this up into Vx, Vy initial. I'm going to also break this up into horizontal and vertical. So I'm going to draw a line down the middle of my page, another line like this. Here's my t-table, horizontal. It's called a t-table because it's a big letter T, right? Vertical. Oh, and I know without even thinking that AX, Rob, is 0 and AY is negative 9.8. Unless we're on a different planet, which we're not. All right, let's find Vx and Vy. To do that, we got to get tricky with it. Let's see. I got adjacent, hypotenuse, opposite. Hey, Zach, which trig function will find Vx? Yeah, I'm asking you. Got an A and an H. Hey, you're a little quicker. Good. So you're saying cosine of 30 equals Vx over 50. One fraction equals one fraction. The 50 moves diagonally to the top. Vx equals 50 cos 30. Vx is going to be .43. You know what? I think because it's a 3, a 0, and a 1, I think going to 3, 6. Well, you know what? I'll go 43.301. Sure. Because that's not my final answer. So far, say good, Naomi? The person I keep missing back there is Jenny because she's right behind Brian. Okay. This is how I learn names. Sorry, bear with me. Vy. Which trig function? Say that again. Vy is what? Mr. Dueck, I can't help noticing in the last question, Vy was sine. And I notice in this question, Vy is sine. I wonder if that's always the case. I wonder if there'd be a clever, easy way for me just to remember that Vy was sine in a projectile. You know, if I was a good teacher, I'd come up with something, but I got nothing for you. And double check me, but I think this one works out to exactly 25, right? I know sine of 30 is a half. I got that one memorized over the years. Let's add those to the appropriate columns. So I have Vy initial is 25. I have Vx is 43.301. What else do I know? Oh, I see a 60. Is that 60 vertical or horizontal? dy equals, but it's not 60. Which column do I know three things in, vertical or horizontal? So I'm going to find time in this column here. How? Put your pencils down, please. I'm looking for an equation that has A, V initial, D, and T in it. Which equation has all four of those? So here is a method which is perfectly acceptable, but I need you to focus because this is the key. I have no problem if you go D equals VIT plus a half AT squared. Don't write this down. I have no problem if you go negative 60 equals 25t minus 4.9 t squared. I did the half of 9.8 in my head already, Rafi. What kind of an equation is this? How do you know? So I have no problem if you are good at the quadratic formula or you have a built-in quadratic solver, then I'm totally okay if you make this equal to 0, 4.9t squared minus 25t minus 60 equals 0, and then bring out the quadratic formula, and you'll get two t values. One will be negative, one will be positive. And if you're good with that, knock yourselves out. What I have found over the years is kids are shaky on the quadratic formula. Who has a solver on their calculator? So if you have a solver, do it this way, probably. If you do not, I have another method which avoids the quadratic formula and is almost as fast. Pick your pencils up, please. Instead of finding time, I'm going to find Vy final. Is there an equation that has A, V initial, V final, and D in it? Thank you for sharing. Is there an equation that has A, V initial, D, and V final in it? The squared one, the squared one. Okay? So let's use that. Let's go Vy final squared equals Vy initial squared plus 2ay dy. Vf squared equals Vi squared plus 2ad. Because I can solve for Vy final very easily. It's going to be 25 squared plus 2 negative 9.8 negative 60. I get Vy final squared equals 25 squared plus 2 times negative 9.8 times negative 60. Now this is Vy final squared. What must I remember to do? What's Vy final? What'd you get? And this is wrong. This is the only risk with this method. Why is this technically wrong? When this projectile hits the ground, what direction is it traveling? Upwards or downwards? So what do I need to insert in front of this answer? That's going to be up to you, Carm. You have to remember that. And the reason is actually this equation here, the VF squared equals VI squared plus 2, it's actually a scalar equation. It never produces a vector answer for velocities because of those squareds. In fact, I know some profs and some teachers don't teach this equation at all because it's kind of redundant. You can do without it. But I find it convenient enough. So Vy final is negative 42.438. How does that help? Well, that gives me one more thing to put in the vertical column. And now, can you find me an equation that has time in it but does not have distance in it? Vf equals Vi plus At. Get the t by itself. I can now go t equals Vf minus Vi over A. I can go negative 42.438 minus 25 all over negative 9.8. Negative 42.438 minus 25 all divided by negative 9.8. And I get time of flight of 6.88 seconds. Those of you that had the quadratic solver, if any of you crunched that, you should have also got t equals 6.88, I hope. The quadratic formula, if you're good at it, is about 2 lines less of writing. But I've just learned the group coming up, for some reason, we don't emphasize the quadratic formula as much in the junior grades, and I find kids make mistakes with it. But either approach is fine. Okay. We are going to the first part of your homework, questions that you're now capable of doing. Number 1, now you can try writing these either on a separate piece of paper or you can do them on here. I think this one I would do on a separate piece of paper. You'll find some assignments is easier to do them writing right on the sheet. I don't care, whatever works for you. But certainly you can do number 1, number 2, and I think you can do number 3. And we're going to pause a little bit there.